like, share, subscribe.
Hey y'all, welcome back. Number 67 says, which of the following statements about the polynomial, and then it's given as x minus 4 squared times x squared plus 4 are true. And then they have three statements about the roots. So let's go ahead and find the roots. So the roots of the polynomial are going to be the values of x that make the polynomial equal 0. Okay, so let's, I'm going to go ahead and just retype the polynomial here, set it equal to 0, and solve this. So notice that this polynomial is already in factored form, so I can use the zero product property. And the zero product property says that if you have a product, in this case I have this times this equals 0, if you have a product that equals 0, then at least one of the factors must equal 0. So what I can do is essentially split each of these factors up and set them each equal to 0 independently and solve them independently. And the x values I'm going to get are going to be the roots. So let's see here. We got x minus 4 squared equals 0. And we also have, let's just do a little copy here, x squared plus 4 equals 0. And here, let's just get rid of those parentheses. Okay, so I'm going to solve these independently. Here I can factor this a little further. We can split this up even further with x minus 4 squared. That's the same thing as saying x minus 4 times x minus 4 equals 0, and we can use the zero product property once again to figure out these two roots. So we're going to split that up one more time and set each one of those equal to 0. Now you might be thinking to yourself, why would you do that? Obviously we're going to get the same answer here. If I add 4 to both sides of this equation, I'm going to get x equals 4. And yeah, I do get that twice. The only reason I'm going to go ahead and actually solve for that 2 times is because this gives me information about the multiplicity of the root. If a root ends up appearing more than once, then we say it has a multiplicity equal to the number of times that it appeared. So since we got x equals 4 twice, we do have 2 real roots. I guess you could say we have x equals 4 has a multiplicity of 2. So one unique real root with a multiplicity of 2, or you can think about it as just 2 real roots that happen to be the same. So over here, we want to solve this one. To do that, I'm going to subtract 4 from both sides. And so after I subtract 4 from both sides, I get x squared equals negative 4. And then I need to take the square root of both sides. And so I get x equals, and anytime you take the square root of both sides of an equation, you do have to include a little plus or minus here. So plus or minus the square root of negative 4, this is not real. Okay, no real number times itself is going to be negative. And so instead what we actually have here is an imaginary number. What we can do is we can rewrite this as the square root of 4 times the square root of negative 1, because negative 1 times 4 is negative 4. The square root of negative 4 is 2, because 2 times 2 is 4. And the square root of negative 1 is what we call the imaginary number. Okay, that doesn't really have it's not a number on the number line. It's considered a complex number. And specifically, this is the imaginary number. So plus or minus 2i. So we have a total of 4 roots, 2 of which are real, and they're the same. So we have a repeated root here. And then we have 2 complex roots, or 2 imaginary roots. So let's look at our statements here and see if we can't decide whether or not they're true or false. So the first one says the polynomial has 2 imaginary roots. That is absolutely true. One of them is 2i, and one of them is negative 2i. The polynomial has no real roots. Well, that is not true because we can see plainly we have 2 real roots. They're both x equals 4. The polynomial has 4 complex roots, including multiplicities. That is actually true. Okay, don't get confused with thinking there's only 2 complex roots. Real numbers are complex numbers also. So if you're thinking about, how are these numbers being classified, any number that can be written in the form a plus bi is considered a complex number. Okay, now you might be thinking, okay, well, I could write this as like 0 plus 2i, so that would be complex. But how would I write this as why would this be a complex number? Well, you could write this as 4 plus 0i, and so it is complex. So all real numbers are complex, all imaginary numbers are complex, but real numbers are not imaginary, and imaginary numbers are not real. So you have basically this big set of numbers that includes real and imaginary. All of those are considered complex numbers. So like if you're trying to visualize this, so let's say this box represents all the numbers, all the complex numbers. Okay, so all the complex numbers that exist can be split up essentially into one of 2 categories. Okay, either they're real or they're imaginary, where real numbers are in the form a plus 0i, and imaginary numbers are in the form 0 plus bi. Complex numbers are all the numbers that can be written as a plus bi. Is that going to fit in there? Okay, that's probably good enough. Maybe I'll move it over a little bit. But yeah, so 3 is also correct. So our answer choices are 1 and 3 here, and so our answer is going to be D. And that's it for number 67. Y'all have a great day.